One thing that has become a large issue in machine learning and health is the idea of trade-offs in performance, and specifically the trade-offs between utility, privacy, and fairness. And so differential privacy is a state-of-the-art technique that's used in other spaces, in imaging and in text, to ensure that we don't have any data point that's too unique pull around a classification too much. And what I mean by that is, if I'm thinking about large tech companies having lots of text data, right now the state of the art is to use differentially private predictions, so that if I always type duck-duck-stone instead of duck-duck-go, it doesn't recommend to me the next time I type duck that maybe the next word is stone. And that's a funny example if it's duck and stone, but if it's a sensitive condition or word, maybe for health about abortion or HIV status, we wouldn't want personal predictions that are very unique to affect our other text examples. And so in this setting, differential privacy makes a lot of sense. But we wrote a paper about the interaction between differential privacy and fairness and utility. And what we found is that if you add differential privacy to standard prediction tasks that we do in the hospital, these are things like predicting who will die, who might need a different intervention, we do really, really poorly. And this kind of utility drop would make the model not usable in a medical setting. So doctors would not be able to use a model that performs at this rate when you add the differential privacy. It probably also doesn't make sense in a medical setting to have this really intense differential privacy construct, because doctors and nurses who are using the outputs of this model already have access to a lot of your health information. We also found, worryingly, that the patients who seem to be too unique and have more of their data redacted and they have less of an influence on the final performance are minority patients. And so specifically in the paper, we found it was Black patients that were having most of their influence in the classification problem removed. And that's not something that we would want to see in practice. And so this is another example of how you can't just throw state-of-the-art machinery at a health problem blindly. You can't naively try to apply these really large levers that we have. There are going to be trade-offs in any system.